Welcome students to my next episode on lens chapter. Okay, in my channel Physics Scholar. So if you missed my previous all episodes, you can see where I uploaded the topic on light, basically reflection applied, refraction applied, the prism, and now I am covering the topic lens. Okay, so I will upload the other topics also. Okay, step by step. Okay, so that the concept should be clear for you. Okay, so if you want to know anything, you can write in comments, and if you want the notes also from me, you can write in comments and provide your mail ID. Okay, so I will mail it to you. Okay, so let us move to today's topic. Today's topic, first of all, what? The ray diagram. Okay, ray diagram. Here for both type of lenses. What two type of lens? What is that? Convex and concave. So first case one. Case one. Okay. Whatever questions may come from this, complete the ray diagram. Okay. So you have to complete that. First you have to know the concept of this. That what when a ray applied is coming and incident on the lens, whether it is a concave or convex, which direction it will flow actually. Okay. Or it will be refracted. And after refraction, in which direction it will go. So when a ray of light parallel to principal axis of lens. Whatever the lens, concave or convex. Okay. So suppose I am drawing first the convex lens. This is the optical center. LL is the lens. So suppose a ray of light parallel. So it is what? If the ray of light coming from this, so this is the focus. Suppose it is f2 and it is f1. It is what? 2f2 and it is what? 2f1. Means double focal length. Here this will be the double focal length. Why? Because if the light is coming from this direction, then this will be the focal point. Okay. So if a ray parallel to the principal axis, then after getting refracted, the ray will pass to the principal focus. Okay. So it is for the convex lens. It is for the convex lens. And when a ray of light parallel to the principal axis, after getting refracted, it will pass to the principal focus. Okay. Of that convex lens. Okay. As shown in the figure. Now, for this type of ray, what is that? It is concave lens. For this type of lens, so this is f2, 2f2, f1, 2f1. Okay. So a ray parallel to the principal axis, and it is optical center. Okay. So what will happen after getting refracted? Yes, in my previous episode already I have shown to you that it will be divergent in nature. If we extend it at the back, so this will meet on the principal focus. Okay. So after getting when a ray of light parallel to the principal axis, in case of the concave lens, after getting refracted, it will be what? Divergent in nature. It will move upward direction. Okay. And what if we extend it at the back, then it will meet, it appears to meet on a point on the principal axis. Okay, this is known as the focus point of this principal focus of this concave lens. So it is the case number one, when a ray of light parallel to the principal axis incidents on convex as well as on concave lens. Okay, then what should be the direction of the refracted ray? So I think it is clear for you now. Okay, what should be the direction of the refracted ray? Now let us move to case 2. Now case 2. When a ray of light passing through through principal focus and incident on a lens. On a lens means it can be a concave or can be a convex. Okay, that means what? Suppose I am drawing a diagram. It is which type of lens? It is convex. Convex lens. Convex lens. Okay. So this is the optical center of the lens. The principal axis. A dash is the convex lens. Now this is f1. This is double focal point. It is f2. It is double focal point. Okay. Now a ray of light passing through the principal, passing through the focal point. Clear? Then what will happen? After getting refracted, it will be parallel to the principal axis. What we have seen? If a ray of light parallel to the principal axis, then it will pass to the principal focus. Okay. So if a ray of light passing through the principal focus, then after getting refracted, it will be parallel to the principal axis. Okay. It will be parallel to the principal axis. So it is for the convex lens. Okay. And for the concave lens, so this is the principal focus, this is the lens. Okay, this is optical center, it is the principal focus. Okay, double focal length. Okay, now what will happen? It will, okay, so if a ray of light will move through this focus point, then what will happen? Okay, so if we draw this diagram, what? It will be like this. Okay, so it should be meet in the principal focus. Okay, so if a ray of light is coming in this path, so after getting refracted, which direction it will move? It will move to this direction. Okay, so moving up next. It seems to meet at the principal focus. So after getting refracted, it will be parallel to the principal axis. Okay, so it is for the convex lens, concave lens, concave lens. Okay, so when a ray of light is passing through the principal focus, okay, in case of the convex lens, it will be parallel to the principal axis. Okay, and here it will be like this. It will move towards away. It will move what, like in this direction. Okay, to the base of the prism. Okay, yesterday in my previous episode I discussed, and it suppose it meets to the principal focus, so it will be refracted due to the lens. It will be refracted and it will be refracted. It will be parallel to the principal axis. Okay. Now case 3. When a ray of light is passing through the optical center. Okay, this is what type of lens? You say convex lens. This is optical center. When a ray of light will fall on the optical center, it will pass in the same path. It is what type of lens? Convex. Convex lens. Okay. And in case of the concave lens, optical center, ray of light fall on it and it will be in the same path. Okay. So when a ray of light will incident on its optical center of any type of lens, whether a concave or convex, okay, then after getting refracted, it will follow the same path. Okay. So these are some concepts of the ray diagram. How the refracted ray will move in which directions. Okay. So if we can remember these rules, we can easily draw it. Now, let us now study the images formed by convex lens. Images formed by the convex lens. First condition, when the object is at infinity. That means when the object is at infinity, what should be the images, position, nature of the image, and why it will be formed. So let us draw. So this is what? A convex lens. Convex lens. Okay. When the object is at infinity, then the rays coming are considered as parallel to each other. Okay. So it is F1 to F1, F2 to F2. Okay. So what will happen? They will, all the rays after getting refracted will pass through the principal focus. Okay. Will pass to the principal focus. That means they are already meeting at this point. So this will be what? Image. Image. What type of image? It will be real. Why real? Because the rays are originally meeting at a point. Then when the object is an infinity, then the rays coming from the object are considered as parallel to each other. So after getting refracted by the lens, they will meet at a point on the principal axis and the real image will be formed. So what will be the position of the image? The image will be formed at the principal focus. Okay. What will be the nature of the image? Real and inverted. Because we know real images are inverted in nature. Okay. What will be the size of the image? Highly diminished. Okay. So this will be the characteristics of the images formed by the convex lens when the object is at infinity. So when suppose the sun, okay, we can consider it is situated at infinity. So the rays coming from the sun are considered as parallel rays. Okay. So if it is parallel to the principal axis of the convex lens, if it incidents on lens, then after getting refracted, it will meet on the principal focal, and the highly diminished real inverted image will be formed and at the principal axis. Okay, at the point of the principal focal on the principal axis. Okay, and the size of the image will be highly diminished, which much smaller than the size of the object. Okay, clear to you? Now let us move to the next topic. Okay. Let us move to the next topic. Okay. Next condition. When the object is beyond to F1. Okay. That means it is not at infinity. It is now beyond 2F1. So see. Let me draw. This is what? The convex lens. Okay. this is f1, this is 2f1, this is f2, this is 2f2. Okay, so the object is beyond double focal length. That means here at one side of the lens, so a ray of light parallel to the principal axis, and after getting refracted, it will move to the principal focus. Clear? And another ray of light passing through the optical center. Okay, so refracting the same path. Okay, so this will be the image. Okay, this will be the image. Okay, so see, ray of light. Okay, from this point passing to the principal focus, another will pass. Another ray will pass to the optical center, and it will meet. So what? They are meeting at this point. So if we draw the perpendicular on the principal axis, so A dash B dash will be the real image of the object AB. So what will be the nature? Nature of the image will be real and inverted. Real images are always inverted. Number 2, side of the image will be diminished, not much more. Okay, and position of the image will be between f2 and 2f2. That means between the focal length and the double focal length on the other side of the lens. Okay, so when the object is placed beyond 2f1 or beyond the double focal length at one side of the lens, okay, it is not an infinity, then what will happen? The ray after getting refracted will meet, and if we draw perpendicular from that point, from that point, then A dash B dash will denote the image of this object, and the size of the object will be slightly smaller than the size of the object. Okay, size of the image will be slightly smaller than the size of the object, and it will form between the focal length and the double focal length. Okay, in between it will form. Okay, so now let us move to the next condition. Now the next condition number 3, when the object is placed at 2f1. That means what? The object is placed at double focal length in front of the convex lens. Okay, so let me draw. This is the convex lens. Okay, this is optical center. Okay, it is f1, it is 2f1, it is f2, it is 2f2. Okay, so this is AB, the object. So one ray will come, okay, and it will pass through the principal focus. Okay, so another ray will come like this, and they will meet here. Okay, so this will be A dash B dash. Okay, so this will be the what? Image of the object. So see, same thing. Now we are shifting the object more towards the lens. First it was at infinity, second it was beyond 2f1. Now again we are shifting more towards lens. It is at 2f1. Now one ray will pass through this principal focus, and another ray will pass through this optical center in the straight path, and they will meet at this point. So if we draw the perpendicular, so A dash B dash will be the image of the object AB. Okay, so see what is the position? Position is at 2f1, means the same position, same distance from optical center to here, same distance between from the optical center to here also. Okay, that means at double focal length. Okay, so the image will be what? Real and inverted. Okay, it is inverted. This is the bottom, and this is top will appear as bottom, and here it is the top, and also the size of the images will be same. So these conditions is very important to remember, because this often comes in the examination. Why? When we can get the size of the image and object same in case of the convex lens. Okay, so when the object is kept at the double focal length, okay, then the image formed by that particular convex lens, the size of the image will be same to the size of the object, and the position of the image will be at double focal length on the other side of the lens. Okay, so that means what will happen now? The image, whatever nature will be made, it will be real and inverted. Okay, real and inverted. Number 2, size of image and object will be same. And number 3 is what? Size of image and object will be same, and position, image will be formed at double focal length, in bracket what is that? 2f2, at the other side of the lens. That means object is at this side and the image will be on the other side. Clear? So this is the third condition. I think it's clear to you. Okay, so now moving to the next. Now let us move to the next point. Condition number 4. When the object is placed between f1 and 2f1. That means we are shifting the object more toward the lens. Okay, convex lens. So now we say what type of lens is this? Convex lens. Okay. Yes. Now it is what? f1 to f1, f2 to f2. Okay. Now here the object is placed. Now the parallel ray will move through the principal focus. Okay. The other ray will move like this. Okay. So they will meet here. So if we draw the perpendicular, so A dash B dash will be what? Will be the image that will be formed on the other side of the lens. So that means what? When the object is placed in between the f1 and 2f1, that means in between the focus and the double focus, okay, on one side of the lens, then the ray will meet at here. So A dash B dash will be the image, and the position of the image will be beyond 2f2. That means beyond the double focal length on the other side of the lens. The nature of the image will be real and inverted and enlarged than the object. Okay, that means what? It will not be diminished or similar side. It will be now enlarged. Okay, so what will happen? Image will be what? Real and inverted. Okay, size will be what? Enlarged than the object. And number 3, position beyond double focal length. What? 2f2 on the other side of lens. Okay. So when the object is placed between f1 and 2f1, then what? Also the shifting of images will be there. The image will be now formed beyond 2f1, okay, 2f2, okay, and the size of the image will be enlarged than the size of the object. So 2 more conditions are there. So I'll discuss it in my next episode. So subscribe my channel and write comments. If you are not understanding any topic, write it also. I'll try to clarify that. Okay. So best of luck. Okay. See you soon.